Hello, I'm Jeff Holtz, Technical Sales Director at Movimento here. Today we're going to be showing an over-the-air update of the Ram 1500 truck utilizing Movimento's OTA platform. The platform consists of three main components: an OTA client, our OTA cloud, and our OTA applications. The OTA client is a software-only component that can exist on any module within the vehicle, and from a single location reprogram all modules within the vehicle. Today we'll be showing it integrated on a post-production telematics control module.
The telematics control module is a conceptual IMX6 based processor product that represents a module currently designed into the vehicle. It maintains communications externally to the OTA cloud via Wi-Fi, Bluetooth, satellite, or cellular. Communications to internal modules would be achieved across current established vehicle networks, for example, CAN, LIN, or Automotive Ethernet. The OTA client software could also be a smart gateway module, head unit, or IVI system. The OTA cloud contains the logic and permissions necessary for the OEM or tier to manage the complete software lifecycle. The cloud is currently implemented on Amazon Web Services. Other implementations include Microsoft Azure or any other Docker-based system.
The last component in our demo consists of our OTA applications. These provide a visualization window of the OTA event as well as provide control of the event. These windows into the OTA process can be located either in the vehicle, accessible via mobile devices, or part of the OTA cloud. In this demo, we have two examples of these OTA applications. On the iPad, you will see an engineering view of the process. From this application, you can select the various vehicles that are currently configured in the cloud. For this demo, we'll select our Ram truck. In the lower right-hand corner, you will see a list of all the ECU modules that are located in the vehicle. The list contains the various hardware and software part numbers installed. The graphical display on the left shows a rough location of where the modules exist within the vehicle. After each update, we can also receive additional diagnostic data, including potentially the vehicle's location, shown in the information below the vehicle. This could be used by the back-end OTA cloud for geofence distribution of updates. The iPad is connected independently to the OTA cloud through either Wi-Fi or cellular, allowing the user to start the OTA event outside of the vehicle, perhaps from inside his home or office, while the vehicle is located in the garage or parking lot. The second example of an OTA application has been integrated into the Conti VP2 head unit. It appears as an integrated Uconnect application. The application will only control and display the progress of the OTA event. In the future, the OTA client software itself could be ported to the head unit to perform a self-update, as well as the entire vehicle through its connections on the vehicle networks. The presentation on this version of the OTA application has been reduced to only display the status messages along with basic control. Display of the hardware and software part numbers are not needed for the end customer. We are now ready to start the OTA process. We can either check for updates from the head unit or the iPad. You'll notice during the demo that both displays will keep in sync through the OTA cloud. We'll start the process by pressing for check for updates on the head unit. The first step will be for the OTA client to perform a synchronization of all the modules in the vehicle. It will query and record any modifications that may have been made to the vehicle since its last check. This may include removal or addition of modules. Perhaps a module has been removed, reprogrammed externally with new or different software, and re-added to the vehicle. This new inventory is sent to the OTA cloud, where an is versus should comparison is made, identifying any new updates configured for the vehicle. Both the necessary ECU module software and control files describing the installation order, pre or post condition, and procedures are downloaded to the vehicle. This allows the installation to occur while the vehicle is offline or disconnected. At this stage in the process, the OTA client has already downloaded all necessary files and identified the updates. You can see that the two modules which have been flagged for updating are the powertrain control module and the instrument panel cluster. On the head unit, you can see the OTA application denotes that we are ready to update the vehicle and presents an Apply Update button. Further conditions could also present a scheduling feature to apply the updates at a future time when the vehicle is not being utilized. Let's press the Apply Update button. The OTA client will then perform the scheduled update procedure. The first action we perform will be to quiet the vehicle network. We perform this task to increase the speed of the update across the vehicle network, as well as to improve its robustness. This step is configured and may be dependent upon which modules we are updating. For this vehicle, due to the quieting of the CAN bus, you will notice the wipers will turn on. This is due to the fault mode analysis of the wipers, which states if it does not receive communications from its rain sensors, it may be raining. Thus, for safety, the wipers are enabled. You'll notice the OTA application displaying various stages of the update procedure, including erasing the module, flashing the module. The progress is communicated to the OTA cloud, so there is feedback during the OTA event. The programming session, you'll see the instrument panel dim and then restart once the update has finished. After the reflash has completed, the OTA client will perform any post actions necessary to complete the update. Examples of common post actions could include clearing of specific update diagnostic trouble codes, calibration learn procedures, or reinstalling user-specific settings. For example, radio presets. As a final step, the OTA cloud will again perform a complete synchronization or inventory of the vehicle to identify that the update procedure has completed successfully. A final transactional log is then compiled and registered with the OTA cloud for archival and future data analysis. This concludes our OTA update.